students, so we're doing definition 4.1. 4.1, 2. And we're going to say a sequence. So the first definition that we wrote was a definition of what a sequence is. And it said that a sequence is a function whose domain is the set n, the set of natural numbers. And that's all it was. And then I just blew it up. Now we're doing the definition of what a convergent sequence is. And the short answer to that is has a limit. So a sequence, and let's use the notation that the Belding and Mitchell uses. From n from 1 to infinity is said to converge to a real, messed up the color here, real number A so a sequence an, that an infinite sequence, right, is said to converge to, because when it clusters around the limit a, and remember it's a real number, that means this is a term. Term in the sequence. If for each, it's going to converge to a real number a, the limit, if, and the condition is if for each and every and each possible and every epsilon a positive number, that will be our within the epsilon business, there exists and a positive number n. So this is it's from this thing belongs to set of natural numbers. And a here is a real number. Such that all the terms after the threshold term, such that all a n's after the threshold term, no s here, all terms an's, threshold uppercase, so I'm kind of like translating the index.
Yeah, I appreciate that.
Yeah, index into the values. Okay. So because the for all this actually should say I missed something. For all n, so this is actually for all n. What is it? This thing. Okay. For all n greater than n. Sorry. For all n greater than, and this goes here. And this. And this is where the difference is. So depending on the book, you're going to have, and we're going to go with this.
Greater or equal to.
Greater than or equal to. So that the threshold term is also a term that clusters. It's not after, but starting with the threshold term, including the threshold term, everything starts to cluster.
Around that
Yeah.
center.
Okay. And then we're going to do for all, and the condition goes for all n greater than or equal to n, we have this situation. And the situation is all the terms, these are the terms that are clustering, the clustering terms after n including the threshold term.
I can't read that. Clustering terms after.
Clustering terms after and including, that's including
Okay.
the threshold term.
Yeah.
So I'm just repeating myself here.
Including.
Yeah, and including the threshold terms are within the distance, are at a distance from the limit a, are within epsilon distance of a. So all the distances between the terms that cluster around a are within epsilon. All the terms are within epsilon distance of the limit.
Okay, wait.
Yeah.
All the terms.
All the terms are within the epsilon distance of the limit a.
Distance.
All of the clustering terms are within epsilon distance, so that's a dash, of the limit a of the sequence. Yes?
Yeah.
Yes, sir. And that is our definition. Let's illustrate this. So here is our number line. We have terms, and we've seen all this before.
Yeah.
That's why it's so beautiful. Where in the lesson there's a review, that's perfect.
Always good for a refresher.
Yeah, it's a refresher within the fresher. Let's put a n here, for instance, just for the hell of it. A uppercase n.
Uppercase.
Yeah. And it says converge to a real number, right? Actually, let's just wait here. So we're going to say there are some. Let's be fair to this line here. It says a sequence is set to converge to a real number A. We got our sequence, and let's just put vertical lines for the other elements of A that are clustering around other terms of the sequence that are clustering around the limit A. Okay, then it says, now let's look at what the second line of the proof says. It says for each epsilon, so the distance, so let's put epsilon here. Let's move the limit up here just a bit. This is A plus epsilon and A minus epsilon. This is a number, this is a number, and these numbers are right here, let's say. Okay, and now it says for each epsilon greater than 0, we chose some random epsilon. There exists a positive number n, okay, such that the terms in the sequence after n including n start to cluster. So let's choose our a positive number n as the index number for this guy here. After that guy, and including that guy, all the terms will start to cluster around here, ANs. And there's only one at a time. Now, if you shrink this, let's say you brought this all the way, epsilon is so close that this is outside of the epsilon from A, we'll have to find a larger n.
Yeah.
If this was 155, we'll need 156, even though 156 is going in this direction. Because the real numbers are,
Oh,
yeah, so if you don't confuse them, then remember, we navigate, we always, and it's true for all kinds of stuff, we navigate the real number line with natural numbers.
Okay, wait, I'm gonna write that down.
Yeah, so let's write that actually. We navigate, this is one of those truths that are really cool. We navigate the real number line, not with increasing or decreasing real numbers, but with the only increasing
Okay.
natural numbers. I added too much to this.
That's all right. I like the caveats that you put.
Okay.
I didn't even, yeah. Only increasing is good.
Mhm. It's actually cool, yeah. Okay, you like that. Only increasing. Let's put this down. Only increasing.
Yeah.
It's kind of like how do you go through, how do you navigate through highways? You need a car.
Yeah.
You don't need a road. So the road, so the road is a real number line, and the car is the natural numbers.
Okay, yeah.
Yes, sir. Poetry.
Yeah.
All right. Okay.
Oh.
And then if this is the case, I'm going to erase this. We still haven't ended.
Don't worry,
We're doing tutorial style.
yeah.
All right. And there is pizza. Okay. If
There's not gonna be pizza. All right, what?
If this is true, a sequence is said to converge. So if a sequence converges because these things are happening, therefore, where it converges to that real number, this real number is the limit. So if the sequence converges to a number A, uppercase A, because we found an n that depends on the value of the epsilon, therefore, the distances of all the terms, the clustering terms from A are less than epsilon, then we can say that A was actually, as the index number for the terms went to infinity, the sequence itself went towards A.
Okay.
So, in other words, this thing is the same as n greater than or equal to n. This is our shorthand, right? And all of this means, so you want to write this down as a shorthand. Sequence. So when somebody says convergence sequence, you think there's a limit. You think there's a threshold term.
Yeah.
You think like that. Okay, let's move on.